So welcome again. So continually we have to be look over. So how this encoder is working on, and how these things are getting into be give the translated outcome. So now we have to be look over into that architecture of encoder. So the seq-to-seq model, it's already said it's having the two components, that is encoder and it's a decoder. The encoder having its set of that RNN and along with the LSTM. Meanwhile, the decoder is also having the set of that RNNs. So now the encoder is provided with the source sentences, and the decoder uses this source representation to generate the target sentence. In case if I am giving one sentence, I saw cat on dash. So next word that should be predicted by that decoder. But at default, always the cat sat on a mat or in some cloth. So we may conclude that, or that RNN by its trained data set, it has to be produced as the output in the decoder. I saw a cat on a mat. So this is one example how the decoder is working. So in that encoder, its job is to process the entire input sequence, one item at a item. That means one word. It doesn't produce an output at each step. Instead, it aims to compress all information from the input sequence into a single dense vector representation. That means the encoder should try to understand, so what is the context behind these things. This vector is called, that is the context vector, or more particularly it is called, that is the thought vector. So this is the final hidden state of the encoder RNN. So for the input, it has to create a one context vector. It has analyzed that each parameter, each word in that sentence. And in the decoder side, its job is to take the context vector from the encoder and generate the output sequence one time at a time, one item at a time. So it uses the context vector as its initial hidden state, so giving it the thought or summary of the entire input. So in the machine translation, now I am giving, that is that one beautiful word, that is the weather is nice, that has been given into the encoder. So that is the LSTM encoder, and then the internal LSTM creates context vector of h, c that has been fed into that LSTM decoder, and then the LSTM decoder has to generate the equivalent value, that is fake bio. So that is the translation for that word from one language to that another language. So this is the concept happened behind in the translation process. Okay, so now quickly we have to see out what happened in that encoder phase and what happened in that decoder phase. So in encoder phase, the word the is fed into the encoder RNN. The RNN produces a hidden state, it's H1. And the next word, the word weather, is fed into the encoder along with the previous hidden state H1. Now the RNN produce a new hidden state, it is called, that is the H2. Now the word is fed into the encoder along with the H2. The RNN produces the final hidden state at H3. The word nice is fed into the encoder along with the H3. Now the RNN produces the final hidden state, the H4. Now the encoder's job is finished. It discards all intermediate outputs and passes its final state, that is the H4. So this is the context vector to the decoder. So this vector H4 is now expected to containing the meaning of the weather is nice. Now what happened in the decoder phase? So in the decoder phase is initialized with the encoder's context vector H4 as its hidden state. To start the generation process, we fed a special token. It is called that is a start or a go into the decoder. The decoder, using its hidden state H4 and the start token, so predicts the first word of the output. So ideally it predicts I1 and produces a new hidden state. It's called that is the H5. For the next step, it takes the word it just predicted I1 and the previous hidden state H5 as the input, and then it predicts the next word fate and produces a new state H6. So this process continues until the decoder predicts a special end of token. That means EOS, which signals the translation is complete. So in this way, the encoder and then so decoder that has to do the translation. So in this place we have to be faces and one issue. It is called that is the information bottleneck. So because this is happened by the fixed size content. So in order to avoid these things, we have to go with that one solution. It is called the attention mechanism. So this attention mechanism becoming as the foundation of the transformer. Once this attention mechanism becoming as the self-attention mechanism, the same thing that has been incorporated in the new era of the transformer architecture too. So thanks for that watching. So rest we have to be discussed on that next episodes.